if you've ever given blood, you know that there's also another thing that you can give, and that's plasma. Typical blood plasma is about 0.14 molar sodium chloride. So this problem wants to know what volume of blood contains 1 milligram of sodium chloride. So let's say that you're a doctor and you want to get a sample of blood plasma, but you want to make sure that it only has 1 milligram of sodium chloride. What volume would you need? So if we look at this problem, we can see it's asking us for volume, and we have given information of 1 milligram and 0.14 molar. So we have a known concentration, we have a known mass, and now it wants us to try to figure out what the volume would be. So again, just like other examples we've been doing, there are two different ways that you could solve this problem, and I have both ways set up for you. The first way is using the molarity equation. So we take our given information, our given mass information, go to moles, and then use the given concentration and the molarity formula to find the volume. So if we take a look at this, we have 1 milligram of sodium chloride. Milli means 1,000. So there are 1,000 milligrams in 1 gram. And then I use the molar mass to get from grams to moles. Molar mass from the periodic table. I find that in 1 milligram of sodium chloride, there's 1.711 times 10 to the negative 5th moles. I now have my moles of solute. I'm going to plug my moles of solute into my molarity formula along with the concentration given to me in the problem, and I'm solving for liters. Notice liters are on the bottom. Be very careful as you solve this problem. If liters are on the bottom, we need to make sure that we get it on the top to solve this problem. This is the type of problem that trips up a lot of people. And it's not that you don't know how to do the problem, it's that you can't solve the algebra. So when we do this, we're going to multiply both sides by x. That gets rid of x on the right side. So now I have 0.14x equals 1.711 times 10 to the negative 5th. How do I get x by itself now? Divide by 0.14. So notice I have x on the left by itself equals 1.711 e negative 5 in your calculator divided by 0.14. When you solve this, you get 1.2 times 10 to the negative 4th liters. Plug that into your calculator right now. Make sure you get that value. If not, rewind, go through how to solve this, and make sure that you can solve that correctly. Now, if you notice, our volume, it's a very small number in terms of liters. So something that might help is to convert it to milliliters. Typically with volume, you're going to either use liters or milliliters. So if you have a pretty small number like this, multiply it by 1,000, and you get milliliters. So I get 0.12 milliliters. Notice, again, my answer only has 2 significant figures because both pieces of given information only have 2 significant figures. So again, this first way was solving for moles using the concentration in the problem and the molarity formula to solve for liters. The second way you can do it, again, is just dimensional analysis. Just set it up as one long problem. Always start with either the mass or the volume, whichever one you're given in the problem. Remember, molarity is a conversion factor. It's a way for you to convert between moles and liters. So I'm going to start with 1.0 milligrams of NaCl. I need to get from milligrams to grams. So my milligrams cancel. I have grams on top. Okay, I need to somehow get to moles. So I'm going to cancel out my grams by using molar mass. So now my milligrams have canceled, my grams have canceled. I have moles, but I need to get to volume. I need to get to liters. If you have moles and you need to get to liters, you use your molarity. So for every 0.14 mole, I have 1 liter. So again, with this, within blood plasma, for every 0.14 moles of NaCl, you have 1 liter of solution. So my moles cancel, now I'm at liters. So again, multiply what's on the top, divide by what's on the bottom, and notice you get the exact same thing as in the first method. Either way you do it is fine as long as you show your work. Okay? I have to be able to see your work to give partial credit if necessary. So looking at these, you get the same answer. Now, you might be saying, well, the problem asked me for volume. Which one should I use? Should I use liters or milliliters? Really, it doesn't matter, but since the number is so small, it's going to be better to use milliliters. Excuse me. So, as you go through this, then, you could tell me how you might make this solution. You might say, you need 0.12 milliliters and 1 milligram of NaCl to make this 0.14 molar solution.